Imagine, just for a second, a completely new kind of battlefield, a war zone totally devoid of human soldiers. Literally, zero humans, no pilots in the sky, and no captains navigating the terrain. Instead, imagine a space where the only active participants are complex algorithms and lines of code, making life or death decisions in mere milliseconds about exactly when and where to strike. Wild, right? Well, welcome to today's Explainer. We are stepping into a totally new era, one that's completely defined by the AI arms race. Driven by massive, recent leaps in machine learning and some unprecedented global export controls, we aren't just talking about generating funny images or playing around with friendly chatbots anymore. No, we are looking at a fundamental shift in the entire global power balance. Today, we're going to break down exactly how artificial intelligence has sparked a high-stakes, invisible war between the world's biggest powers. Now, historically, military dominance was pretty straightforward, right? It was measured in physical payloads and kinetic force. Nations secured their borders and projected power using gunpowder, steel, and eventually the sheer destructive, terrifying force of atom bombs. But today, we're moving away from that traditional kinetic battlefield to an entirely algorithmic one. The true arsenal of today is made up of data and processing power. Modern warfare leverages things like AI-driven drone swarms, fully autonomous tanks, and these incredibly sophisticated cyber weapons that can just penetrate critical infrastructure without a single physical boot ever hitting the ground. It sounds like science fiction, I know, but it is our modern reality. The rules of engagement have completely transformed. Military supremacy isn't about who has the biggest standing army anymore. It's all about who possesses the absolute best predictive algorithms and, crucially, the raw computational power to actually run them. All right, let's dive into Section 1, the power players. We're looking at the global superpowers. So who exactly is fighting this invisible war? Well, the map of global influence is currently being completely redrawn by an intense, high-stakes rivalry between major global superpowers, specifically the United States and China. Now, both of these nations are mobilizing entirely different strategies to reach the exact same goal: total AI dominance. On one side, you have the U.S. pouring literally billions of dollars into initiatives like the Department of Defense's Replicator project. The strategy here relies on something military strategists call attributable mass. Basically, that means rapidly producing and deploying thousands of low-cost, autonomous systems by tapping into the country's massive commercial tech sector. Now, on the flip side, China has publicly laid out an incredibly aggressive, very specific deadline, the year 2030. By then, their target is to become the ultimate, undisputed global leader in artificial intelligence. They're driving this through a strategy of state-sponsored civil-military fusion, meaning anytime there's a breakthrough in civilian AI research, it's immediately integrated into military applications. So, you've got one approach that's decentralized and hardware-focused, up against a sweeping, centralized national mandate. Moving on to Section 2, the speed of war. Because here's the thing, just having the technology, that's really only half the battle. The ultimate unbeatable advantage in this new arms race isn't just about what your machines can do, it's about exactly how fast they can do it. The defining metric of modern warfare is absolute speed, and that brings us to something called the OODA loop: observe, orient, decide, and act. For decades, this has been the core doctrine for human commanders. You observe the enemy, orient yourself to the threat, decide on your tactic, and then you act. But AI completely flips this framework on its head. In the observe phase, AI sensor fusion can now process millions of data points from satellites and radar instantly. In the orient phase, predictive machine learning models are forecasting enemy movements before they even happen. We aren't just speeding up human decisions anymore, guys. We are actually starting to remove human cognition from the loop entirely. Just think about the microsecond for second, 0.0000001 seconds. Try to wrap your head around that. Well, it takes a human commander agonizing, slow seconds or sometimes even minutes to process a complex battlefield threat and authorize a strike. An advanced AI system executes that entire OODA loop we just talked about in mere microseconds. Think about the strategic reality of that math. It's staggering. We're moving from a paradigm of having a human in the loop to a human on the loop to potentially being entirely out of the loop. If your military is relying on human reaction time to fight against a fully autonomous, AI-driven force, honestly, your human oversight actually becomes a critical liability instead of a safeguard. In this arms race, a country that lags behind in algorithmic processing speed is going to effectively lose the war before a single command is even spoken out loud. Which brings us to Section 3, the hardware bottleneck. So, we've been talking a lot about software, code, and abstract data, right? But here is the crazy plot twist of this whole dynamic. This invisible, highly abstract software war is actually completely dependent on a very physical, highly contested bottleneck. The digital arms race has a real-world anchor, and that anchor is advanced semiconductors. Look, you can have the absolute most brilliant algorithmic models on the planet, but without sub-5 nanometer silicon chips to process the massive compute loads that AI requires, your algorithms are basically just lifeless code. It's like having a Ferrari engine without a drop of fuel. And this is exactly why the global supply chain, companies like TSMC in Taiwan, and sweeping geopolitical export controls like the CHIPS Act are completely dominating international policy right now. The ability to manufacture these incredibly complex microscopic nodes is highly, highly concentrated. Whoever controls the silicon supply chain controls the processing power. And in today's world, whoever controls the processing power dictates the entire global balance of power. And that leads us to Section 4, the ultimate dilemma. Because beyond all those billions of dollars and the fancy sub-nanometer lithography, there is a really heavy complication sitting right at the heart of this autonomous future. We are staring down a massive legal and ethical vacuum. Think about it. If a machine is operating totally autonomously, making decisions in a literal microsecond, and it makes a lethal error on the battlefield, whose moral responsibility is it? The concept of meaningful human control is right at the center of this intense debate among international legal scholars today. Under the Geneva Conventions and international law, accountability for war crimes has always relied on human intent and human agency. So, if an autonomous drone misidentifies a target, who takes the blame? Is it the programmer who trained the neural network? Is it the commander who deployed the fleet? Or is it just the black box algorithm itself? The terrifying truth is that this technology is scaling and deploying at a speed that vastly outpaces our ability to create the international laws needed to actually govern it. So, as these superpowers race to build out their autonomous arsenals, we're all left to grapple with the ultimate consequence of this technology. The fusion of algorithmic code, advanced silicon, and microsecond processing speed is creating a future that we absolutely must actively govern before it inherently governs us. Will artificial intelligence ultimately act as a sophisticated, automated deterrent that brings about a new era of global stability, or are we actively engineering a completely uncontrollable threat? By understanding the deep mechanics of this geopolitical race, the raw computational speed of the tech, and the physical bottlenecks controlling it all, we can start to really comprehend these massive, silent shifts happening right under our noses. I really hope this explainer helped bring some clarity to what is, honestly, a highly complex global reality. Keep questioning everything, keep learning, and hey, make sure to subscribe for more deep dives, because understanding the mechanics of our rapidly changing world has literally never been more vital.